Okay, today we're going to start a new chapter called as progressions. Right. This chapter is also known as sequence and series. So we'll start off with sequences. What is a sequence? Correct. So you have heard of sequences. Anyone, can you tell me what is a sequence?
It's a series which are uniform in a way.
In
For
uniform in a way.
example,
Okay. Can you give an example? Some
it
example.
might be your even numbers 2, 4, 6, 8,
Two,
10,
four, 6, 8. Okay. Okay. 10. So basically, we're saying the
It
some
will
numbers.
have something. It will have something in common.
It has something in common. It has a pattern, right. That is called a sequence. Okay. So it's not exactly a series, because what is a series? When I add these numbers, right, the sum, this is what we call as series. So the difference between sequence and series is the same, right? So sequence, yes, it has a particular pattern, right? For example, I could guess what would be the, say, 20th term. Can you tell me what is the 20th term here? What would be the 20th term? It's simple, right? 40, correct. 40, right?
Yeah.
So we wrote a sequence. See, we did 2, 4, 6, 8, 10, right? Then we could guess the 20th. This one. It was directly simple. It was 2 into that number, maybe, right? So every number is 2 into that number, so we will get it easily. So that is the pattern we observed. So when the pattern is very specific, right, the advantage is any number I ask, you can guess. For example, if I ask you the 2000 term also, 2000 term, still you will figure out, right? It's just 4000, right? This is a simple pattern, but we'll see some more advanced patterns and some other progressions called as arithmetic, geometric, so on. There also you'll find that yes, there's a pattern and we can figure out which terms using some formula or something like that, right? So first, there's some terms we define. We use something like an, right? This is to denote which term it is. For example, in the sequence I've written down, right, 2, 4, 6, so on, I'll say the first term a1 is 2, correct? So it is easier to recognize. When I ask you a3, you know directly it is the third term I'm talking about. So a3 is nothing but 6, right? So if I say a20, so this is nothing but 40, what we have figured out, correct? Looking at the pattern. So sometimes they use this tn also, which also denotes the same thing. It's specific to arithmetic progression, right? But for now, I'll just mention it here so that there's no confusion. Okay. The usual notation is an, right? But we use tn. Tn also means the same thing. So t1 is 2, right? Something like that. So what is this n? N denotes the term, the nth term which I'm talking about, right? If I'm talking about the first term, I'll say a1, or whenever I say n equal to 10, that means I'm talking about the 10th term. Now let's see some random sequence I'll write. Okay, you'll tell me what is, see, 0 1 0 1. Now that sequence was increasing, right? This is a random 0 1 c. Sorry, I have to, yeah. So what would be the say 2021 term? Zero, right? So what is the pattern here?
Plus 1 minus 1.
Plus one minus one. Okay, you can think of like that. But in a generic way, if I want to write, how will I write it?
A odd number. Also.
Yeah. So you're saying the odd terms are zero, correct? Odd terms are zero and even terms are one, right? So you can write it in any way you like. So you can say something like this: a 2n is equal to, say, 1, and a of 2n, say, plus 1 is equal to 0 always. Obviously n belongs to integers, correct? Now I mean to say, see, somebody can give you something like this, right? They can give you in a formula, right? It is still a sequence. What they're saying, see, what they're saying is every even term is 1, every odd term is 0. So you should figure out that, okay, they're talking about something like this, right? Another, I think, famous sequence you would have seen, say, sorry, not a2, let me generalize it, say a of n plus 2 is equal to a n plus 1 plus a n. Have you seen this? What is this? Yes, Fibonacci sequence, right? But there is some more details which have to be added. So we start with a naught, which is equal to say 0, and a1 is equal to 1. Just look at it, right? So I have fixed a0, which is 0, and I've fixed a1. Now tell me what is the next term. See, a0 is 0 and a1 is 1. What would be the next term? From this formula, when I put n equal to zeros, look at this. a2 is nothing but a1 plus a0, correct? If you want, we can shift it, not an issue. I can start with n equal to 1. If you want to ask why should I start with n equal to 0, there's no issue. So as such, I can always shift it from say a1 equal to say 0 and a2 equal to 1. Okay, then the formula would change obviously because our first term is 0 itself. So it would be a3 is equal to a2 plus a1. So n is equal to 1 is where I start. Right? So what is a3? A3, we know what is a1 and a2. So it is, say this is 1, this is 0. So the sum is 1. Correct? So what would be a4? Sum of the previous two terms, right? Sum of the previous two. It would be 2. Again, sum of the previous two terms, 3, 5, 8, right? So they just, what they did is gave a simple formula like this. So it forms a sequence. Correct? So whenever they give something like this, always take some example and see what the sequence means. Okay. Just because they have given an a and it need not be complicated. You can always apply some values and check. Okay. So there's one way of writing. See, after sequence, we'll come to series. We won't try to find the sum of anything, but there's a notation which is used called as summation. We'll try to use it once. So summation. Have you seen this notation before? Yeah, you have seen. Okay. So if I say summation of say summation r, say r equal to 1 to n, what does it mean?
1 plus 2 plus 3
1 plus 2 plus 3 up to n. Is it clear for everyone? This is.
I don't understand.
You didn't understand. Okay, no problem. So, see, instead of writing this sum like this, right, what we do is we use a notation called summation. This is called summation. For summation, it's like a formula. Okay, it's a formula. So, if I say summation of, say, r is a variable here. Okay, r keeps on changing. So, what I'm saying, r is equal to 1 to n. So, r is starting from 1 going up to n. Clear till now? Now, I'll just write the summation. So, what is the first term? R is equal to 1. When I put r equal to 1, I'm getting 1. Fine. Then it is summation. Therefore, I have to add plus. Okay. Now, the next term, r will increase. For the next term, r will increase. It will be 2. So on, it will increase. It will be 3, then 4, and so on. Till it says the last term is n. So till n, it will increase. That's what summation is. For example, if I write summation r square, okay, again r is equal to 1 to n. So what would this be? Yes, Stuti, you can answer. Yes, Stuti.
It would be 1 and then it would be 4, then
Yeah.
9.
So similarly, I'll simply write it 1 square, 2 square, 3 square, so on, right? Correct? Up to what would be the last term?
n square.
N square. That's it. Fine. So that is when summation is given, you are writing this. If this is given, you should be able to write the summation part also. Okay. Let us see our example. We had written what? 2, 4 and so on, right? So can you tell me what is it in summation? 2 plus 4 plus 6 plus 8. I'll just simply write a random number, 200. Can you tell me what is this in summation? I'll try this.
Plus 2.
Summation of what? So it is read something like this. I'll just read this, just make a note. This is called summation r, where r is from 1 to n. Okay. You tell me in the similar fashion. So this is summation r square, where r starts from 1 and goes up to n. Right? So what kind of summation is this?
Summation r plus 2 where r is 2 till n.
Okay, I'll write down your answers. Then we'll figure out. So you're saying summation r plus 2, where r is 2 to n.
Sir, I have no idea. So n will be 198.
N. Okay. Still, do one thing, Stuti. Can you wrote down this formula, right? Right? Can you try and from the formula expand and see whether you're getting what you have tried? Just try whether you're getting that. Okay. Yeah, Karthik. Okay.
Summation of 2n where n is from 1 to 100.
Summation of 2n where n is from 1 to 100. Yes, Upasana.
So summation of r where r is equal to 2
R is equal to 2 to
200.
2 to 200. Okay. Fine. Not bad. All are giving different answers. It's fine. We'll just figure out what. Pranav, what is your answer?
Summation of r plus 2 where r is equal to 0 till 198.
Okay. R plus 2 where R is equal to 0, starting with 0 to 198. Okay. There's one doubt here. Sir, will it be the sum of negative integers up to n if n is negative? I'm not able to figure out what exactly is your doubt. Arjun, can you speak up?
If the number is negative, like if r is 0 and
Okay.
n will be like minus 2.
We usually go from positive, so increasing order, so that there's no confusion, right? So if you want to start from a negative number, why don't you start something like this? Say r is equal to minus 20 to 20. That's fine, I think. Right? As long as you specify that these are integers we are looking at, you can start with a negative number. But there's no particular, you can write it, but I don't see a particular reason you're going from 0 to negative, right?
Yes.
Yeah, got it? Yeah. We usually, for all these sequences, we use positive just because this terms are usually we start from 1, not even 0, but usually 1, right? But there's no particular rule. You can always start from a negative side, not an issue. Okay. Yes. Now we have got different answers. Obviously, only one is right. Okay. So let me just write your sequences so that it's clear. I think what you people have wrote down. First one.
So mine will be r equals 0 itself.
Oh, yours will be r equal to 0. Okay. It's fine. We'll just okay. This is wrong. You mean okay? Fine. We'll try this then. R equal to 0. Can you tell me what is the first term of the same sequence? What is the first term?
2.
2, right? Well, expanding it is 2 plus. What is the next term?
3.
It's 3, no? How is it 4? See, you are increasing r by 1, correct?
Yes.
You are increasing r by 1, correct? Now, based on your formula, at least it is 3. In your formula, nowhere it's mentioned it is increasing by 2. Isn't it? How will I know that? Because in the formula, what I do, I told you. First I use 1, then I go to the next integer. This means r is 1 to n. That means I keep on increasing for the next number. See, here also you did the same thing. No? From 1 you didn't go to 3, correct? You went to 2. Similarly here, after 1, you have to use r equal to 2. Right? So this formula won't work. Right? So what else we have? We have summation. I think we can see the same issue here. Right? When you write summation r equal to 2 to 200, now our first number is fine. Second number have to increase by 1, it will be 3. Again, it's not a sequence. Correct? Here, this is a different problem altogether. There's no variable at all. So I don't know from where to start and where to end. So you can have a number. There's no issue. I'm not saying you can't. For example, I can have summation 1 of n equal to 1 to say 10. Can you tell me what is this equal to? Anybody?
1 plus 2 plus 3.
No.
This is 10, sir.
The sum is 10.
Plus 1. 1 plus 1 plus 1.
Why? Because there is no variable, right? So what is it? Each term, see, next term, I'm trying to increase n by 1. N is 2. But in the term, there is no n at all. So it will remain 1 only. Understood? Why was the term here changing? There was r, right? For r, I was putting values. Here there is no r or no n, right? So it remains the same. So this is nothing but sum of 10 terms, which will be 10 itself. But remember, you can't simply write summation 200. Or at least mention the limits. From where to where? Otherwise, what will I add? How many numbers will I add? Right? Okay. Usually they use this summation. Okay, I have to add a page. Let me write it down. Sometimes I simply write summation r. Okay, without writing the limits. Whenever I do that, I mean that I'm talking about 1 to n always. Okay. If I don't mention, it's always assumed that it's from 1 to n. Okay, because it's standard notation. So the standard notation is say r equal to 1 to n, but we know r is a variable, so I'll write 1 to n, right? Or if it is 1 to n, I can simply ignore that. I'll write summation r. It is understood that it's from 1 to n. Anything else I'll specify from 2 to say n minus 1 or anything else I can specify. Is it fine? Is it clear? At least summation part. We are not trying to find the sum now. At least writing in the summation part should be clear. Okay. So this is a simple problem. So it always won't be like expanding. Always easy because you're simply putting values. But while writing the other way, you just look at the pattern. You should find a variable which changes. See, here the variable was 2r. The first term is 2. Next term was 4. So 2 into 2. Right? So the general term will actually give you an idea what the summation is. How did you find 200? Tell me. I asked you the 100 term, right? How did you find 200? You multiply by 2, right? So that r is that term. If you are able to find the general term, right? The general term of this sequence is 2r, correct? Then I write that in the summation. The general term is in the summation. Always. Any sequence you take, the general term you write in the summation. So how do you denote the general term? We usually use the notation an. So we know a1, a2, a3 is the first, second, third term. So nth term would be an. Right? I usually prefer ar. Right? Because sometimes there's a confusion. For example, see, when I use the variable r, I'm saying, where is it? We've used somewhere, say 1 to n, right? Now, if you use n as your variable, it will get confusing. 1 to n again, right? So, if you keep the variable something different like r, it will be always easy. N would be the last term, right? It is not the general term, it will be the last term. So, it will be clear, right? So, r is varying from 1, 2, 3, 4 up to n. So, it will be very clear. So, that there's no confusion. If I use n again, it will be confusing. N is varying and n is the last term, it won't make sense. Correct? So, we'll try to use AR wherever is necessary. Usually, the formula in the textbooks are in terms of AN. So, it becomes a little bit confusing. Fine? Okay. I think this should be clear for the initial part. Let's simply write the first 6 terms of this. Quickly write down. Do we know what is that exclamatory mark n factorial? No?
Yes, sir. No, sir.
Okay, those who don't know, just say no, don't worry. Okay, if somebody knows, doesn't mean you need to know. Right? So you can simply, yeah. Okay, fine. Let me tell you in a simple term. I don't want to go in detail. It's there in permutations later, I think. N factorial is nothing but the product of all the numbers from 1 to that number. Example, 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. What is n factorial? N is a generic number. So, n into n minus 1 into n minus 2. I don't know how many numbers are there. From up to 3 into 2 into 1. Something like this. Is it clear? The formula is clear at least. That is more than enough for you to solve this problem. It's fine. We just have to write the 6 terms. Okay. So it's read as n factorial. Okay. Product of all the numbers from 1 to n. Okay. One more point. Previously, we had used summation like this. You can, for product, you can use this symbol, pi. Similar fashion. If I say pi of r, say from 1 to n, this means nothing but your product of all the numbers from 1 to n. Okay. Need not worry about it. Nobody usually asks pi, but I'm just mentioning if in case you're interested. Yes, Saurav, can you tell me what is A1?
Yes, sir. So A1 is 3 to the power 1 by 1 factorial instead of 3.
Okay. 3 power 1 is 3 and 1 factorial is also 1 because 1 factorial is nothing but up to 1. There's only one number. So nothing to multiply at all. Okay. A2. Yes. Continue. We can quickly finish this.
Okay, should I continue?
Yeah. Continue.
A2 is 3 squared by 2 factorial, which is 9 by 2, which is 4.5.
Okay, you can leave it as fractions. I'm not really interested in the values. Okay.
Okay, sir.
We just want to know whether we can expand. That's all. Okay. A3.
27 by 6.
3 cube by 3 factorial. So 3 cube is 27 and 3 factorial is 3 into 2. So 3 into 2 into 1. So which is 6. Right? If you want, you can simplify. There is 3 common. So it will be 9 by say 2. Is it same? Yeah. Okay. Somehow you got A3 equal to A2 anyways. A4.
Sir, 3 to the power 4 by 4 factorial.
Okay.
81 by 24.
81 by 24. We'll keep it as it is. We won't go to simplify. If again there will be a 3 common because see one of the hints is see in the 4 factorial. See this is only 3 powers. Okay, this is only 3 powers. So denominator should have a 3 so that you can divide. So there is always a 3. 4 factorial means what? 4 into 3 into 2 into 1. You'll always get a 3. Next 3 you'll get only at 6. After that there won't be any other common factors, right? Because you should get a 3. Otherwise you can't have anything common. So till then you need not worry. 1, 3 you have to cancel. Anyways, we'll keep it as it is. So this is 3 power 5 by 5 factorial. Everybody gets an idea, correct? I hope it's clear. Any doubts here? So this is 3 power 6 by 6 factorial. You can keep it as it is. It's fine. Okay. Now just imagine if somebody had given you this sequence, right? We never could have guessed it is this, right? Even though we would have tried different things, we would never guessed it is something like this. Okay. Therefore, on theory part, there's nothing much in sequence and series, right? Even arithmetic progression is very simple, but they can ask really difficult problems. Fine. So we learned what are sequences, what are series, right? Okay. So for mathematics at least, we want more well-defined sequences, right? Now I know I can always keep a pattern and ask you what is it. It would be a GMAT problem, isn't it? Like for example, I can give a more interesting problem if you like. Say 1, 2, say 0, 1, 2. Then I'll start say 1, 2, 3. Then I'll tell you the pattern. So something like this. I can ask you what the number is, right? You can figure out. You will eventually say if I ask you the 100 term, you will somehow find some pattern and tell me what the 100 term is. These kind of problems are there in sequences, right? But when we come to sequence and series, right, what will happen is adding these terms is really difficult. So every problem we have to treat it differently, find some pattern and solve, right? But arithmetic progression, as the name says, related to sums. Okay, so arithmetic progression will be something like this. So you'll have your first term as 1, then the next term, if I add, it's 3, so the difference is 2, correct? So the difference keeps on remaining the same. So if it is 3 now, the next term will be 5, and next term will be 7, next term will be 9, and so on. So the difference is common. Okay, it doesn't matter what sequence you take. If it is arithmetic progression, the difference has to remain common. Okay, that is what is arithmetic progression. So this is one of the series, arithmetic series. So just for sequence, you'll write 1, 3, 5. It doesn't make a difference, right? You'll just put commas there. It's a sequence. Sorry, not 10. It should be. Oh, you have written 10 here also. It should be 11, right? So on. Up to, you can write the general term if you want. I can directly write We'll see how to write this directly. Anyways, fine. So is it clear what is arithmetic progression? Yeah. So the
Is this
yeah.
is this denoted with plus sign or a comma?
The plus sign is for series, as we discussed, right? Arithmetic series is this plus sign. Comma is the progression or sequence, arithmetic sequence. It's called as arithmetic progression, AP. Usually we use the term AP. Okay. So it would be used with comma. Now the advantage here is, see, not only finding any term, we can find any term we like. And we can find the sum also. Right? So we'll see. We'll take a generic equation and try to solve. Okay. Anyways, let's see. Let's see the common notation used here. Okay. So what we use is we use A. Similarly, we use A1, A2, A3. That is the same. Okay. For nth term, we use AN. For the first term, we use A1, A2. That remains the same. Okay. But for the first term here, we use the letter only A. Okay, it's a common notation which is used. A. Can you tell me what would be the next term? It would be something like this, right? A plus D. So D is nothing but called as your common difference. That is the definition itself, right? The difference remains common, correct? That's what is arithmetic progression. So it's named that way. So it's common difference. Fine. So look, can you tell me what would be the next term? This was A. This is A plus D. What would be the next term? A plus 2D. Right. I told you the difference should remain the same. So next would be A plus 2D. And next would be A plus 3D. Correct? Yes, Swasti, can you tell me what would be the 10th term? So, for example, this is the first term, this is the second term, this is the third term, this is the fourth term, right? What would be the 10th term?
Sir, A plus 9D.
A plus 9D, correct. Yes. So, Dhruvi, can you tell me this also? What would be the general term? General term, AN.
Sir, it would be A plus N minus 1 into D.
Correct. Correct. Can you see the pattern? It's just an observation. We didn't even do anything, right? We observed that it was A, then it was A plus D. So A plus 2D. Next is A plus 3D. So the D part was one less than the term we were taking, isn't it? So the general term, if you want, you can use AR, as I said. So it's A plus R minus 1 into D. Okay. They use AN or TN. These are the two different notations which are there. So don't get confused. Both are the same thing. Okay? Right? For the sum, what we do is we use the notation Sn. Sum which fixed is Sn. Okay. For a particular number, like we use AN or T. Is it fine till now? All right. Okay. So what we know? We know that any term I take, say A4 minus A3, if I do, what is this equal to? What is this equal to? D. Because we know it's a common difference is D. It's common. But if I say A6 minus A3, what is this?
D.
This also should be common, right? It would be 3D. It won't be some random number because every number increased by D. From A3, I added D, I went to A4. I added D, I went to A5. I added D, I went to A6. So there are 3 Ds which we get. So it's 3D. Correct. Fine. Now for the same sequence, right, I'll try to find the sum. What is the sum? A plus D, A plus 2D. I'm trying to find the sum of all these numbers. Please try. A plus 3D up to, because Sn means sum of first n terms, right? So I'll do up to n. So which is A plus, we already know the nth term is this. So what is this sum? Please try to find out and tell. Try to solve this. We just have to add them somehow, club them and get a formula. This is the formula for the sequence. Okay. So see, we're just trying to find the sum. Alright. So how many A's are there? Okay. Because there are n terms, there should be NA, right? Correct. So A is very clear, n into n, not an issue. Not an issue. Right? I just combine all the a's because obviously common terms only I can add, right? I can't add mixed term. What about the rest of the term? The rest are all d's. So if I take d common, okay, I'll take d common. Look at the term. It says d plus 2d. So 2d will be 2 will remain. So 3d 3 will remain. So on up to n minus 1. Isn't it? That's it, right? That's all. A I combined. There were n a's. I wrote n into a. Right? So d's I combined the numbers. So what is this sum? 1, 2, 3 up to n minus 1. Do we know this? Yusupasana, how did you complete it?
Sir, I took the values. I considered n as 5, so I kept on adding a plus b plus a plus 2b till 5b. A plus 5b.
Okay.
After that, I got 6b plus 6a plus 15b.
Yes. That is correct. But you see the problem there. Your formula you can use only when they ask you 5 terms, correct? What if they ask you for 6 terms or 7 terms or 10 or 20 terms? That time you can't use your formula. So I want a generic formula. See, whenever I say a plus n minus 1d, right? Any problem given, if I use this formula, I'll get the nth term. Right? For example, if you want, you had given this 2, 4, 6, correct? Correct. 8 first sequence. Let us use this general term. Tn is a plus n minus 1 into d. Can you tell me what is a? A is 2. What is d? D is 2 again. So n is the generic term, n minus 1, correct? So this is 2 plus 2n minus 2. So 2 and 2 will get cancelled. It's 2n. Didn't we get 2n that time? Right? We got 2n. Right? So it would work for any sequence. Obviously, it should be arithmetic because the formula is for arithmetic. As long as arithmetic, we can find the general term, not an issue. An term. Right? Similarly, I want something for Sn. Okay. So that's why I'm not taking any particular number. I'm taking general n itself. If I figure out this sum, next time I need not add all those numbers. I can simply apply the number in this formula and get the idea. That's why we went from sequence series to a specific arithmetic progression, so that we could find the sum easily. Right? Okay, it's fine. Any idea? You tell me if you can. Do we know how to find this sum? Sum of first natural numbers, some 10, 1 to 10. Do we have any idea how to add them? 1 to n into n plus 1 by 2. Okay. Tell me why, Siri. Why should it be n into n plus 1 by 2?
Because it is like 1 plus 2 plus 3 n minus 2. So n we can take it as n minus 2.
Let me write down what you're saying. I'm not sure. So 1 plus 2 plus 3 up to n, right? You're saying this is n into n plus 1 by 2. Okay. So what is the justification? Why is this formula there? Yeah.
Inside the bracket, it is like 1 plus 2 plus up to n minus 2. We need to simplify that. Different formula.
No, that's fine. That's fine. But why is this true? I'm not sure whether this is true. That's why I'm asking you. How do we get this formula? Did you check this is true for all n? Or do we know it's true? Any justification why it's true? No. Anyone? Yeah, just as a formula we remember. Okay. It's true. The formula is correct. Sum of first n natural numbers is n into n plus 1 by 2. But why anybody? You people did the derivation, right? In school. Can you tell me this? Was it done in a similar way?
No, sir, we did not combine.
Okay. Tell me your method. We'll try your method. It's fine. We'll keep this aside. We'll yeah. What should I do from your method?
So S of n
Yeah.
is equal to a plus n minus 1 into
S of n.
plus
This is T of
plus
n.
a
Okay. Plus.
no, a plus n minus 2.
Okay. You want to write in the reverse order. That's what you're saying.
Yes.
Okay. So what he's saying is, so we have written this in this order, right? Right? A increasing order, correct? The same term, S of n itself, we'll write in the reverse order. Understood? So this term will come first here. Next term would be n minus 2. Correct. Here also the previous term would be n minus 2. So on. So the next term would be say a plus n minus 3 into d. Then we'll leave it. We'll come to the last terms. Last term should be these only. We're coming in this order. Correct. Last term would be the same. It would be say a plus d. Then last term would be a. Same sequence. This is written like this. This is written like this. Okay. What next?
Okay, add them.
Add these two, right? So add these two. How we add? We add the first term here and first term here. Okay. Both are the same sequence. So if I add on the right hand side, I'll get Sn plus Sn. So 2Sn. Fine. Sn plus Sn, 2Sn.
Yes.
Okay. So here let me see. I'm adding the first term only. Please look at the first term. It is say 2a plus n minus 1 into d. Fine. All agree? Okay.
Yes, sir.
Second term. Now look at the second term. Again, we are doing the same thing. A plus d and this. So a plus a is 2a. D part. Let's look at the d part. This is d plus n minus 2 into d. Isn't it again n minus 1 into d? Right? If you want to add and see. So this is d. This is n minus 2 into d. So we are adding 1d. Correct? So it will be n minus 1 into d.
Yes, sir.
Right?
Yes.
Great. So can you see the next term also? Next term. It is the same thing, no? Yeah, I'm adding 2d to minus 3d. It will be n minus 1 into d again. Alright?
Yes, sir.
Okay. Now the question is, how many such terms are there? Each of the term we are saying is this only. Even the last time, if you want to check, last time we have written in the same fashion. No? We already added this. It's the same thing. So it is 2a plus n minus 1 into d. Alright? So how many such
Yes.
terms? How many such terms are there, Saurav?
And terms.
N terms, correct. N terms. So this is n into 2a plus, let me write it clearly. N into 2a plus n minus 1 into d. Fine. So, but this is twice Sn. So I'll simply divide by 2. So this is the formula. We see this formula, just to note, any sequence is given, right? You just have to see how many terms. For example, they'll ask you 20 terms, then where there is n, you put 20. So 2a plus n 19d. A and d you will get in the sequence only. A is the first term, d is the common difference. You'll just get the sum. That's it. Nothing much to do. That's why it's a generic formula. Okay. Now, we are saying this is true. Any justification here? Many people knew this is true. N into n plus 1 by 2. Why?
It can be proved in a similar class.
Yes.
Plus n minus 1.
Correct. Correct. We knew how to do this there. We could have done this here only. Okay. So we'll do this here itself. So we'll write in the reverse fashion n minus 1. N minus 2 this would be. Last term here it will be 1. If it's 2 here it will be n minus 1. Right? So again if you want I'll name it as say capital A. Or let me change the letter itself. No confusion. B. Doesn't matter. Right? This is also B. I wrote in the reverse fashion. Okay. Now I'll add these 2B. Let me see, add these terms. So first term is n plus 1. Next term is n minus 1 plus 2. Again it's n plus 1. Next term n minus 2 plus 3. Again it's n plus 1. Last term again n plus 1. How many n plus 1s are there? N, right? Because there were only n terms. So this is equal to n into n plus 1. So B is nothing but n into n plus 1 by 2. Is the formula clear? Now this is true only for sum of first n natural numbers. Okay. So don't apply the formula randomly. For example, if somebody asks you 10 plus 11 plus up to 100, don't apply the formula. This is not true here. Because it's not starting from 1. Unless it's starting from 1, you can't apply that formula. You can find the sum here easily using the formula. but you can't directly apply it. Okay, that you think of how to find the sum. Okay, let's go back. We didn't complete our solution. We were discussing why is this formula correct. We got a proof for this, right? And we'll go back and apply in our formula here. This is n into a plus d into, this is n into n minus 1 divided by 2. Let me correct and write it in the same formula. Okay, n here it was n into n plus 1, the term into the next term, correct? But here the sum is only up to n minus 1, not n. So the last term is what? N minus 1. N minus 1. The next term is n minus 1 plus 1, which is n. So it is n into n minus 1 by 2. Is it clear? Now just simplification, nothing. N is common, take n outside. So what remains? A plus n minus 1 into d by 2. Take the LCM. N into 2a plus n minus 1 into d divided by 2. Same formula we got. Nothing much. We'll apply the formula. Is this an arithmetic sequence? Is this an arithmetic sequence? Yes, right. Yes. So Sn, what is A? A is 1, correct? A is 1. D is what? D is also 1. Common difference is 1. N is n only because we are finding the general term. Let's apply and see. So n is n. So n by 2 into 2a. 2a is 2 into 1. Just checking what we derived till now is correct. Plus n minus 1 into d. D is also 1. Fine. Let's see what it comes out to be. N by 2. N minus 1 plus 2, which is n plus 1. This is the formula we got, right? So this is another proof. I didn't use this proof because we didn't derive this formula at all. To derive this formula, if I use the proof, it won't make sense, right? So we derived in a different way. But once you know arithmetic series, you can directly use arithmetic series because it is the same. And this is a very important formula. You have to remember this, right? Directly. Sum of first n natural numbers, n into n plus 1 by 2. So try to find the sum. Here it is not exactly arithmetic yet, but because there is n here, right? So I just wanted to explain AP first, right? Then come to this. So try to solve all the 3 parts. So expand, see what the sequence is, then apply. Anvisha, can you tell me for the first one?
No, sir, I was not able to find the answer. I'm getting confused while solving.
Can you tell me how to expand? This can we try this? How will I expand this? Right? How will I write this?
So I'm not sure, but
Yeah.
I think it's 5.
First term would be 5.
Yeah.
What would be the second term? You're right. Yeah. What would be the second term? 10. Correct. Yeah. Why not? What is the third term?
15.
15. Right. So in general, what is the nth term? Last term would be
5n.
5n. Correct. So we have to find the sum of this is what is asked. Correct. So what type of sequence this is or series? You can see the difference between these terms, right? Isn't it constant?
AB.
Right? 10 minus 5, 15 minus 10. It's constant, right? So it's an arithmetic progression. So what's the formula for AP? Sn is equal to
N into 2a plus n plus 1
n minus 1,
n minus 1, okay, bracket d.
yeah, into d divided by 2, correct? Yes? Okay. Please pay
Yes.
attention. We just discussed the formula. All of you have to remember it. You can't just say you don't know at this point. Okay. Okay. So we'll simply apply the formula. That's it. We want Sn. So nth term is n because we don't know what n is. It is just a generic term. A we know. A is equal to 5 because A is the first term. D is also equal to 5. So we'll simply substitute in the formula 10 into n minus 1 into 5. So this is nothing but say n by 2 into phi n. This is minus 5 plus 10, which is plus 5. So this is your formula. If you want, you can take the phi out and simplify. Phi by 2 into n plus 1. Right? If you already knew the formula, there's another way. You need not even do this. Phi is common, correct? Phi is common, correct? Throughout all the terms. So isn't it 1 plus 2 plus 3 up to n? Right? Don't we already know the formula for this? Sum of first n natural number, n into n plus 1 by 2. You can see both are the same. Right? Just in this problem, usually you won't get it directly. Okay. But here, without using the AP formula also, because we know the sum of first n natural numbers, right? We can do that. Anyways, it's fine. B part. This is direct. Can we expand? Yes. Pranav, can we expand? Yeah, it's fine. Just expand and tell me what are the terms. We'll check. 0 to 3. 2i plus 1. Okay. So what is the first term? 1, because I is 0. So it will be 2 into 0 plus 1. What is the next term?
3.
3. Yeah. 2 plus 1. Next term would be 5. Then 7, right? We are asked from 0 to 3. So there are totally 4 terms. Okay. So the sum is direct. We can simply add them. We need not even use any formula because it's very small. So this is 8 plus 8, which is 16. Okay. Fine. Similarly, we'll complete this part. So directly I'll write because we already seen one. Phi divided by k factorial is 0 factorial plus phi divided by 1 factorial up to 4. This is phi divided by say 2 factorial plus phi divided by 3 factorial plus phi divided by 4 factorial. This is the sum what we want. Okay. So phi is common. I'll just keep it out. We'll see. So first term is 1, second term is also 1, third term is 1 by 2, then is 1 by 6, then 1 by 24. If you want to simplify, okay, let's do it. Because LCM you have to take. LCM is 24, correct? So first two terms, okay. First two terms, it's 2 into 24. Okay, I've combined this two. This is 2. So 2 into 24. Next term, 12, because if I multiply 2 to 24, I have to multiply with 12, right, to get to 24, right? Just taking LCM, 6 into 4 and 24 into 1. Okay, so this is the simplification what we can do. So denominator is 24. 5 into this sum, this is 48. 48 plus 12 is 60. 60 plus 4 is 64, 65. If you want, you can still multiply and write it. 5 into 5, 25. 5 into 6, 30, 325. Fine. So usually the options.
Could you repeat the calculation part again?
I just took the LCM here. LCM is what? 24, right?
Yes.
So 24. So this is 2. So this had no denominator. So I have to multiply both numerator and denominator with 24. Right? Here this is 2.
Yeah.
So to get 24 I have to multiply with 12. So for 6 I have to multiply with 4. For 24 I have to multiply with 1. I just added this. That's it.
Okay, sir.
Yeah, then
Thank you, sir.
just multiplication. Yeah. Fine. Let's go to the next problem. Quickly we can do this. Then we have lots of problems. Okay. What do we mean by nth term? Nth term is nothing but an, correct? An or tn. Right? So we know the formula, it is nothing but a plus n minus 1 into d. That's all we are trying to find out. So it's given what is a. First term is minus 1. So a is minus 1. That's it. A is minus 1. What is d? D is given, common difference is 5. That's it. Right? We got our formula. Just to simplify, this is phi n minus 5 minus 1, which is minus 6. Fine. So that's why this is just the formula given. We just have to remember the formula and just substitute. They're direct problems. Okay. Stuti, can you tell me the eighth term of the arithmetic sequence is 25? How do I write that in a statement?
Sir, does this mean n equal 8?
Yes, n equals 8, eighth term, right? So how to write it down?
Do we use the formula for this?
Yeah, you have to use the formula. That's what I want you to write it in a statement. What would be that statement? Mathematical statement, I mean. Yeah.
I don't know, sir.
You just tell me what is the general statement, general term. For nth term, what would you do? For nth term, how do you find out?
A plus n minus 1 into d.
A plus n minus 1 into d, right? What is asked right now? Eighth,
The first item.
no. Eighth term is told, right?
Yeah,
Eighth term means A8, correct?
yeah,
What is A8?
25.
Yeah, the A8 is equal to 25, but in the formula, what is it equal to?
I don't know, sir.
Here you put n
No,
equal.
n will be,
Yeah.
n will be a, but
So
what will a be?
it's fine. It doesn't matter. No, you tell me what the formula becomes.
A plus 8 minus 1 into d.
Yeah, A plus 70, correct. So that's all we know. It's fine. We don't have the information of A or D. It's okay. What else is given?
The 12th term.
12th term. What is 12th term?
A plus 12 minus 1 into d.
So A plus 11D. Fine.
Yeah,
So this is 41. Now can you solve these two equations? There are two equations, two unknowns, correct?
yes, sir.
So we'll get A and D. That's it. So this is how you use the same information. See, it's the same formula, but we just write it down, we get it, right? We wrote what is A8, A plus 7D. So if I subtract the two equations, say this is 2, this is 1, if I do 2 minus 1, so this is 41 minus 25, which is 16. And here A and A will get cancelled. 11D minus 7D, which is 4D. So D is what? D is becomes 4. Just substitute in one of the equations. Any equation is fine. First equation, fine. 25 is equal to A plus 7D. A is nothing but 25 minus 7D. So 7D is nothing but 7 into 4. So what is A? 28. So minus 3. So once you know A and D, you can write any sequence. That's it. Right? So A is minus 3 is given. Next term is A plus D. So minus 3 plus 4 is 1. 4 plus 1 is 5. Again add 4 is 9. Add 4 is 30. First 5 sequence. First 5 terms of the sequence. I hope it's clear. Any doubts?
No, sir.
Okay. Others, if you have doubts, you can directly ask. You may not wait. Okay. If anything is not clear, then ask what is. So this is a see, whenever they tell you say 20th term, even if you don't know A and D, please write this equation down, right? That will see what you have to do. This has only two variables, right? If you get one more equation of the similar fashion, you can always solve them. You'll get your problem. Is it fine? Okay, this is important. Okay. Similarly, this is direct. So I'll give you say 10 seconds. Yeah. So those are answered are right. So find the 10th term. 10th term means A10. A10 means A plus 10 minus 1 into D. That's all I have to find. Right? A is what? A is given. That begins with 8. So first term is 8. Common difference is told to be 20. So 9 into 20 is 160. Oh, 188. Right? 180. 180 plus 8, 188. Fine. These are direct formula based problems. We'll come to more complicated problems. Okay. Let's see what the problem says. So it says that first row has 20. Okay. Next row has 22 seats. Then it continues. Totally there are 30 rows. Fine. I've just have to, it's arithmetic progression, right? So each row we're increasing the seats by 2. Okay. Up to 30 rows. That's it. So 30th term, you have to figure out what it is. Now we know how to write a generic term because it's an AP now. It's 20 plus n minus 1 into d is 2. So we can figure out what is the 30th term if needed. Okay. Otherwise, you can simply directly try to find the sum. Right? Because we don't need the 30th term as such. So we'll try to find the sum. N by 2. It's 30 by 2. Right? So into 2a, which is 2 into 20 plus n minus 1. So it is 30. Let me write 30 only by Sn. So S30. So 30 minus 1, which is 29 into d. This is the sum we are trying to find out. So 30 by 2 is 15. Here it's 40. What is d? D is 2, right? Let me substitute that also. This is 40 plus 29 into 2, which is 58. So this is nothing but 15 into what? 98? Right?
Yes, sir, repeated.
Yeah, so this is nothing but 15 into 100 minus 2. Correct? So 1500 minus 30, which is 1470. Easier to calculate that way, others you have to multiply. That's all. Okay. Fine. I think many of you have got the answer, so it is clear. Others just practice it once more. Just once you figure out the sequence, it's all about application of the formula, nothing else. Okay. What is the value of n in the following expression? Okay. Can n be no? It's equal to 289. No? Is n 289? No. You're trying to find the value of n. Okay. Many of you have got the answer. So it's fine if not. We have a lot of problems. That's why I'm just going a bit fast. Otherwise, I would have given more time for you to solve. Okay. Look at the problem. So it is nothing but sum of n natural numbers, right? You already know this, right? But you can see that it is coming both sides. It's coming as sum of natural numbers, right? But we don't have n for both. I think there's only one n, right? Correct. So
Yes, sir.
let me write the sum from 1 to n like this, directly, right? So this part. So here. So what is it? N into n plus 1 by 2. This is known. Fine. For the other part, here, there is sum of again first n natural numbers, but not up to n minus 1. Correct. So the formula is nothing but n minus 1 into n minus 1 plus 1, which is n, by 2. This is told as 289. That's it. You have to solve this equation, problem solved. So numerator is what? Divided by 2. So n square plus n square minus n. Okay. So n minus n will get cancelled. So this is nothing but 2n square by 2. So 2 and 2 will get cancelled, which is a 289. N square equal to 289, n can be 17 or minus 17, but we are talking about numbers here, right? We're talking about terms. So we are taking as positive. Fine. So n equal to 17 is the solution. If any doubt, please ask, otherwise we'll go to the next one directly.
Can I take like from 1 to n minus 1 and n to yes, sir.
It will be the same thing, no? And this formula will come here, this formula will go there. That's all, right?
Yes, sir.
It won't make a difference. Yes. Okay. Sorry. Anyone with the answer?
So 600.
600? I don't think so. It would be 600. This look at this. Oh, sum of all terms. Oh, maybe. Yeah. Yeah. How did you find out?
So like first I found a and b because we get two equations.
Yeah. Tell me what are the equations? Look.
A plus 26d is equal to 2.
A plus 26d. This is the 27 term. Yeah. So it is A plus 26d is equal to 2. Okay. What next?
And a plus 173d is equal to 4.
Yes. A plus 173d is equal to 4. Okay. Now?
Then I found a and b.
Oh, you subtracted these two.
Yes, sir.
Okay, so let's see what we get. So 173 minus 26, correct? So it is what? 7. So it's 6 minus 2. 147d, right?
Yes, sir. Yes.
So d is nothing but 2 by 147.
Yes, sir.
What is a?
A is 242 by 140.
Okay, let me use the first equation to find it out. So 2 minus 26d. So d is nothing but 2 by 147. So 26 into 2 is, say, 52 by 147. So taking LCM, 2 into 147 is what? 150 into 2 is 300. So 296, right? 296 minus 52, right? Correct. So it's 294. So this is 242, correct? Now it's fine, Saurabh?
Yes, sir.
Okay. Fine. So what we need to find is sum of all terms. Okay. So sum of all terms means S200, sum of all terms, correct? So
Yes.
it is n by 2, 200 by 2 into 2a plus n minus 1. So 199 into d. Did you multiply all this and figure out it was 600? Saurabh?
Yes, sir.
Okay. Fine. So 2 into A, let's see. Where is A? A is here. So 2 into 242. So it's 484 by 147 plus 199 into 2 by 147. Let me directly write it down. So it is what? 400 minus 2, right? So it is 398 divided by 147. Okay. So what the sum is, because the denominator is same, let me keep it as it is. So 147 into, you have to just add these two numbers. So 8 plus 4, 12 carry. So 9 plus 9, 18. So 3 plus 1 is 842. So I think 147 goes in 882, right? 6 times. If I'm not wrong.
Yes.
Yeah? Okay. So this is equal to 600.
Actually, a plus 2 plus 190 can be directly formed out by
Yes.
adding a of 27 and a of 170.
Yes, yes. That's why this problem was given, right? Not everything need to be calculated. They specifically gave you these two numbers, right? Just look at this sum. So what you wanted to find S200? You wanted 2A plus 199D, correct? Correct? Can you see if you add these two, what do we get? It's 2A plus, so 173 plus 26 is 199D, right? So the sum was directly equal to 6. We already knew this. So here, if you simply put 200 by 2 into 6, you'll get this 600. Right? There's nothing wrong in your method. It's fine. Okay. It's just that not all the problems can be given. They won't give like this. But in case they give, right, we can solve it quickly. That's all. Okay. So that's why they give what this random numbers 2 and 4, so that the calculation becomes tedious. Correct. If you do the usual method. But if you are able to spot it, right, directly you'll get the answer. Okay. Something like NTSC problem. Right? That's what they do. There will be a straightforward method, correct? But if you go with the usual route, it will be a bit time consuming if you do properly all these steps and so on. Okay. Anyways, so I hope it's clear. So always see what you want. Okay. If there might be cases where what you want that can be directly got by some other method. Okay. Let's move on. Because we have learned trigonometry, we can do this. Okay, Ashutosh, tell me. How do you get the angle? What information do you have? How do we find? We need sine to b, so obviously we want b, right, to get the answer.
Yes, 60 degrees.
How do you get 60 degrees?
A plus C is 180.
A plus b plus c is 180 degrees. We know the sum of the angles of a triangle is 180 degrees. Fine. So
And A plus C by 2 is B.
a plus c by 2 is b. Are we sure it's always true?
Yes.
Uh,
Because A
why? How do you know it's true always?
because
Why is a plus c by 2 always equal to b?
because A will be of the form A plus D and A will be of the form A and B C will be of the form A plus
Okay,
D.
okay. So you're saying if I write this as a plus d and a plus 2d, yeah? If I write, because it's an AP, correct? It should be in this form, a plus d and a plus 2d. If I write like that, so a plus c, so a plus 2d by 2, you can see that if I add this is 2a plus 2d by 2, which is nothing but if I take 2 common, it's a plus d. This is nothing but b. This is always true then. For a generic problem, if I prove this is true always. In general, also it's true. It's not hard to see, but I just wanted to know why exactly, right? Yes. So a plus c by 2 is always b, or a plus c can be written as 2b. This is what you mean, right?
Yes.
So this sum will be 2b plus b, which is 3b is equal to 180 degrees, or b is equal to 60 degrees. So once you figure out what is b, sine 2b is nothing but sine of 2 into 60, which is 120 degrees. This is nothing but, I don't know, directly if you know it's root 3 by 2. If you don't know directly, it's 180 sine of 180 minus 60 degrees. In second quadrant, sine is positive itself, so sine 60 degrees, which is root 3 by 2. Okay. One more thing. So, yes.
Then, can you explain how we got TB over there?
Which one? 3b. Did you get to know a plus c is 2b? Is this clear?
Yes, it is.
So a plus c is 2b, then total sum is 3b, right?
Yes, but
So in simple words, see, I need not take a plus d, a plus 2d always. Look at an easier way. I'll take this as a plus d, middle term as a. So I added d to get my right hand side term, c. On the left hand side, I just subtract d. Why do I do this? Look at this. Now look at the sum of these three terms. Right? It is a minus d plus a plus a plus d. Can you see that d will get cancelled and directly I'll get 3a? Right? So that's the same logic. I just chose the term so that it cancels out. So it will be easy. In this case, middle term was b. So it is in AP, right? So b plus d, whatever this d is, it doesn't matter for me. So b minus d. I can't find a and c. Remember, that's why they specifically asked you sine to b. You can't find the values of a. You need the common difference for it. You can't find the value of a or c. You can always find the middle term. That's the reason we can take something like this. Middle term you can get. Okay, just make sure any of these problems will be solved in the same way. If there are 5 terms, so it doesn't matter. You will get the middle term. Any other term you can't find out unless the common difference is mentioned somehow. Okay, make sure you make a note of it. Okay. Siri, did you solve it? Okay. Okay, let's try. Yes, Siri, tell me what is the information given so we can try. Yes, Siri, can we write it down?
Is
Yeah. So what is given?
it's given a plus a plus a and
Yeah.
the
Yeah. So how to write it down?
So I actually started with A1 as A plus B,
Okay.
and I did A2 as A plus, sorry, A1 as A, and it was A plus B.
Okay. This is A. This is A plus D. So on, right? This is A plus 19. A D.
Yeah.
Yeah.
So A2 plus A5, I did it as A plus B plus A plus 4D,
Yeah.
and so on.
So A plus 7D. Right. Okay. Up to A 98 is A plus 97D. Correct. This is 205. Okay.
So here I found the sum.
Yeah. What is the sum? What is the sum?
So 96A.
Are there 96 A's?
97A.
97A. Are you sure there are 97 A's?
Oh no, yeah. So I found that the pattern is 2, 5, 8. So there are in between 2 terms and C.
Oh, yeah. Okay. Okay.
So then, and there also there is a pattern. So I think there are 33.
Yeah, it's not 97, right? So A's how many A's? 33. Okay. Okay. So 32 or 33? Can you confirm?
Is I check.
Yeah. 33 is?
33, sir.
33. Everybody agrees. If everybody agrees, it's fine. Okay. And now the question is, how do I confirm there are 33 A's? What is this?
So that 2, 5, 8 all the way to 98 is again.
Yeah. So 2, 5, 8 and up to 98, correct. I just want to know how many terms are there. This is an arithmetic progression. How many terms are there will tell me how many A's are there, correct. That's it. So nth term is 98. So the formula is an is equal to a plus n minus 1 into d. So I want to know how many terms are there. I want to know what is n. So 98 is equal to 2 plus n minus 1 into common difference is 3. Correct. So this is 96 is equal to n minus 1 into 3 divided by 3. So this is 32 is n minus 1. So n is nothing but 33. So it's clear. There are 33 terms, so many a's will be there. Okay. So I just wanted to clear that we are not guessing it's 33. We are clear that there are 33 terms. So we know there are 33 a's. Okay. What about D?
And in D also, there is a pattern 1, 4, 7, 2, 9.
Yes, it's another arithmetic progression, correct?
Yes.
So you have to add these terms now. So here directly you can use Sn formula. So now we know there are 33 terms. So directly instead of Sn, I'll put S33. Okay. So it is 33 divided by 2 into 2 into A, which is 2, plus 33 minus 1, 32, into D is 3. So this is the sum. So 32 into 3 is 96. 96 plus 2 is 98. 98 divided by 2 is 49. We'll just multiply 33 by 49. So it's not needed, right? I can keep it as it is, I think. Okay. Why I'll tell you. Because I saw 33a here. That's why I feel like keeping this as it is. 33 into 49 is equal to 205. Fine. So 33 is common, as you said. So it's a plus 49 into d is 205. Can we use this information somewhere?
Yeah, A plus 49 will be.
Okay. So let's see what is asked in the problem. What is asked? So sum of all terms. Sum of first term to 99 terms. So that what is that sum? Sum of 99 terms. So it's 99 by 2. Okay, 99 by 2 into 2a plus what are the terms? 99 minus, so 98 into d. Oh, this is what is asked. We need not even have simplified. Probably we could have kept it here only and got our answer. Anyways, it's okay. Come here. So look at this. I'll just remove 2 outside. So this 2 will get cancelled with this 2. So 99 into a plus 49d. Is it fine? Is it fine, others? Are we getting what we want?
Yes, sir.
Yes, sir.
Yeah? Sure?
So how do you do that substitution? So can you just repeat?
Which substitution this?
Yes, sir.
This is S99, no? I use the formula Sn is equal to n by 2. Sn formula. Sn is equal to n.
Okay, sir. Okay, sir.
Yeah.
Okay, sir.
Yeah, I just substituted 99 in that. That's it. So, see, that's why whenever you have to find something which A and D is not given, they will give some other information. You have to figure out what information is given. You have to just try to extract it. Okay. So now you can see that this information is 205 by 33, or you can take 33 common here. Anyways, we'll directly do it. 99 into this is 205 by 33. So 33 is common. This is 3 times. So it's 615. Is it okay? So always some of the information would be given. So it is not always that A, D and simply substitute in the formula. Okay. For simple problems it is like that, but usually it will be involved like this. Okay. Now still there are a lot of problems. I don't know what to do. Should we continue in the next class or should I give it as homework? So I don't think. Okay, I'll do one thing. We can I'll keep it as homework, right? We will solve and come. I'll solve in the next class. Okay. So write down the problems quickly. Okay. I'll directly next class you solve and come. If you can't solve, don't worry. Okay. You need not Google and figure out the answers. Okay. You just try. If you're not getting it's fine. I'll solve directly in the next class. Okay. So quickly write down the answers. Sorry, questions. Done? There are some more problems after. My next class will be next week, so you have enough time, I think, to solve. Done? If you're not done, tell me. I'm just quickly moving. Next class starting, I will start solving these problems. Okay. I won't give you time now because it's as homework, so you would have already tried them. Then after that, I'll continue with the topic GP and HP and so on.
Then
Okay.
So one minute, second, please call up. This is for one. Done, sir.
There are 5 more.
then
Yeah. Not done, tell me again. I'll go back. It's okay.
sir.
Sorry, others are done. I'm just listening to one and just going. Yeah. Okay.
Okay.
These are difficult ones also. Some are difficult. Okay. Do not worry if you're not getting it. But while trying these problems, just by trying also you'll understand a lot of things, right? It will improve your basics. Just so you have to try. Done? This is fairly
Then sir.
okay. Done?
Yes, sir.
Okay. Just 1 minute. Okay. Done?
Yes, sir.
Last problem. Do we know what is mod of something? Do you know this?
Yes.
Yes.
Okay. Then you can try this. Arithmetic mean. Do you know the arithmetic mean of say 3 numbers? What is it? Arithmetic mean of 2 numbers. Do we know? Average. Yeah. Average is 2 numbers. If 2 numbers are A and B, it's A plus B by 2. Right? So what if the arithmetic mean of 3 numbers? A plus B plus C by 3, right? Use average. So if there are n numbers, A plus B up to C up to whatever this n is, okay. Sorry, A n. Let me write some K. That's fine. So divided by n. There should be n numbers here. It's better to write A1 plus A2 up to AN divided by n. So this is the average, what you mean, right? So depending on the number of numbers, you take the average. It's not always divided by 2. Okay. 2 numbers divided by 2, 3 numbers divided by 3, so on. We'll learn mean anyways because that's asked maximum value of the arithmetic mean. So that's why I'm just mentioning. Okay, that's it from my side. Any doubts? Can you show the 4th question? Okay, is this noted down? Done?
Yes, sir.
Okay, then I'll go back. I don't know which is fourth one. You have to tell me, Shishit. Huh? Is it this? One comma, two comma. This one. Next or before? This one. Yeah. Once done, let me know. Anything else? Anybody? Okay. No? Let me show the first one. First one. Which is the first one? Okay, this you have solved. So this is the first one. Yeah.